What's going on, guys? Welcome to section 3 of the Solventless Mesclatore Q&A, where we are talking about the Solventless Mesclatore, the bubble hash machine that we make, and answering some questions that we got from you guys. So thank you for listening. If you haven't done so already, you find these videos useful, subscribe. If you have any questions, drop them in the comments section and we'll be sure to answer as best we can. If you disagree with something that I say, again, drop those comments below. That's a really good question. We did a lot of modeling when we made our design, and we wanted to have something that was backwards compatible to the trolleys that already existed. As you know, we make a Bucher type trolley for filtration, and we wanted to apply that same platform to the agitator-based system for the solventless system. And we did a lot of simulation to understand how things were going to model, and we were happy with the designs. When we actually tried this in the lab, it was good. We got the agitation that we wanted. Things were there, but as I've spoken about in previous videos, there are some drawbacks to using a round tank. And so we set off to perfect the tank, right? All of these modifications that we would need to perfect the tank. One of the designers proposed just using a square tank. We modeled that, and it was very interesting how using a square tank totally modeled better, and the agitation that we wanted, the turbulence where we wanted it at the interface was so much better. So instead of pursuing the fix to tweak the round design, we decided to go with this proposed new square design and explore where that went. And we did all the CFD simulations to try to find out what needed to change in the tank to make it successful. And what ended up happening was that by having a square tank, we were able to reduce the overall tank height, which made getting into the tank easier because the tank height itself was lower. We were able to increase the volume from a fill volume of 80 gallons to 100 gallons with an operating volume of from 65 to like 80 gallons. We no longer needed to use baffles. We were able to use a bag just like we were doing with a round tank. And so many different things changed. Not only that, but when we started to try to fix the drawbacks of having a square tank, for example, the bottom, those calculations forced us to go in a certain direction on how to manipulate the construction materials. And so what ended up happening was the design of the tank bottom had to be very specific and a specific shape and contour to get the fluid dynamics that we needed, specifically to get the draining there, because one of the situations that we saw with a round tank was we have a slope bottom, and that typically is great for draining. So we weren't going to have that similar situation in a square tank. That forced us to change the shape of the bottom, and in so doing, it totally affected the fluid dynamics of the tank bottom. That slanted V shape that we have in the bottom totally disrupts the fluid dynamics underneath the impeller, underneath the filter grate. As I mentioned previously, the impeller also pushes water out the bag, down the filter grate into that tank bottom. But the way the shape is, the water pattern changes down there, and so there isn't a consistent flow. There isn't a lot of turbulence. So what that means is all of these trichomes just settle. They're allowed to settle, and there is a limited opportunity for the trichomes to leave that bottom. And so that allows those trichomes to settle, and they don't go back into the impeller. They don't get beat up. They don't get degraded. So these are some like really cool features that we kind of like stumbled into trying to fix one thing. We noticed that there was a significant improvement from this design to having a round tank or having a flat bottom. So all of these things really ended up selling us on changing to that design. The other thing that also helped was because the tank was now lower, it was larger volume, we were able to reduce the ceiling height of the machine, of the system overall, from a 10-foot ceiling to now you only need an 8-foot ceiling to operate the machine, because of course the agitator needs to raise above the height of the tank. So that was very interesting, and all of those issues that I've mentioned just made it a no-brainer to go from a round to a square. The other thing that also happened was, by going to a square, not only were we able to increase the amount of gallons that we were able to put into the machine, but one of the cool features that we liked about the trolley to begin with was that you can take your trolley anywhere. You know, you can move it from one process to the other. They're very light, they're very easy to move. But we're used to operating in an industrial environment. A lot of the users that are making bubble hash don't have such large facilities, and so these trolleys wouldn't go through a normal doorway. They would go through a larger doorway like we're used to in bigger labs. So by going to a square tank, we were able to reduce that diameter, that length of the trolley, to make it able to go through a standard doorway. So that was another improvement. And so all of these things just started to add up, and then we were just sold on the design. And it was so successful that we've actually filed a patent for that design, because it is very innovative and it does so many things that just nobody else is doing. We think it's a very unique design, and it solves so many problems. That's why we changed to a square tank. Here's a cutout of the new tank. And so what's so special about that bottom is what I said before, the fluid dynamics. More importantly, the fluid dynamics are not there. Fluid doesn't move around so much in the bottom of the tank. And that is extremely important, because when you're using hand paddles and you're agitating by hand, typically you produce better quality hash, because the trichomes are allowed to settle, they fall to a false bottom, and there is no turbulence at the bottom, so the trichomes stay undisturbed, they don't get damaged. Typically in a machine, especially a machine that has an agitator on the bottom, it continuously beats up and beats up and beats up those trichomes. So our design has three things. It has a bag that filters out the trichomes, so the trichomes can make it through the bag, but not the biomass. Okay, so that creates resistance, right? That creates a barrier for particles to go one way, and it's not so easy to go out another way. Why? Because there is positive pressure, right? So the water is flowing outside the bag. So for a trichome to go back into the bag, it's challenging. Number two, the impeller is pushing part of the fluid down to the bottom of the tank, and there's a filter grate. And again, that bottom grate promotes fluid going through the grate but not coming back out. Third thing is just if you look at the bottom, it is sloped and V-shaped at the same time. And so this shape totally is not good for mixing. It's not good for agitation. So all of that water current that is moving to that bottom of the tank just really doesn't flow correctly. So what happens is the trichomes accumulate in the center channel of this tank, and they lose all of that energy. So if you notice, you see how it slopes down. There's two different slopes. So all of your trichomes accumulate in this area here, and on a continuous process, it's easier for them to get out the valve. And the whole point of this is that they don't continue to get beat up, because they can settle down there, they can rest, they won't go back into the agitator, they won't get beat up. And so that great quality hash that you're making, that 5-star full melt that you're making, is not going to get damaged by the impeller. One of the important processes in manufacturing bubble hash is to soak your biomass correctly. If you look at Frenchie's videos, typically Frenchie covers the biomass with ice. That's just to keep the flour submerged. Some users don't use ice, and if you do not properly soak your material, it can create contaminants. And for the agitation cycle, it's important because it increases the viscosity of the solution. So we wanted a simple design to help users soak correctly. And so one of the ways we decided to do it is by using an insulated lid. So the actual lid is insulated, so when you're soaking, you cover this up and it'll keep that water cold, and it has an adjustable plate that you can ensure that the biomass is going to be completely submerged underwater, so you get that necessary soaking and you don't have, typically you'll have the top that isn't properly soaked and the bottom is really well soaked. We don't want that. We want to make sure that the whole biomass is completely soaked. And so that's what the lid is there for, and it comes with every trolley. We think it's a really cool feature, and it's going to save you guys a lot of headaches. You can use ice if you like. We prefer not to use ice because ice creates shear. It's a zone of shear, and shear grinds your material, which causes contamination. But our machines are designed with you in mind, so if you want to use ice, you can. We just suggest that you use very little or none at all. You can also use ice to chill the water if you don't have a chiller. If you have a chiller, yes, you can use a chiller as well. We can provide a heat exchanger and a chiller to chill your water in the tank, or preferably you will have an exterior tank to pre-chill your water and then just add that water to the tank. So it's very versatile on how to operate, and the actual tank itself, it's very thermally efficient. So your cold water is going to stay cold for a very long time. Really, the only heat transfer that you should be concerned about is of the actual mixer, because the agitator, it actually introduces heat. That rotation, that agitation, that energy goes into your system as heat. So every now and then you're going to want to add a little bit of ice to modify that temperature depending on how much time you're agitating, or you can also add a heat exchanger and a chiller to keep that temperature cold. But the temperature difference is minimal. Typically, you do not need to modify the temperature throughout the process, but it is a possibility simply because the actual agitator adds energy into the system. But if you're just soaking or anything like that, very little energy loss. So your cold water stays cold in that tank through that cycle because it's so thermally efficient. Yeah, absolutely. You can put them in a walk-in cooler or even a walk-in freezer. There is no problem. You can leave them there. It can freeze. This temperature doesn't affect these thermoplastics. It's typically not necessary to freeze these or to leave your biomass in the freezer because they're so energy efficient. Typically, you just throw your cold water in there, and it can be in a cool room, an air-conditioned room as you normally would, 65, 55, whatever. And they are mounted on casters, so got little wheels that make it really easy to take anywhere in the lab. So if you do want to put it in a cooler, they slide right in and they are the right width to fit through a normal doorway. So there is that benefit of it. But yes, you can put them in a cooler. Some of my favorite features of the machine, of course, are the PLC, because the PLC is what really allows all of this automation to happen, which makes this system so great because you can process many batches with repeatability. Every cycle is going to be the same. You're going to agitate the same frequency, the same time. That's going to help you have consistency in your manufacturing process. So the PLC is what does that, and the PLC does a lot more things. It can do data logging. It can save you the recipes of the stuff you want to do. It can monitor the temperature and so many other things. So definitely that the PLC is one of the coolest features. The trolleys themselves, there's so many little innovations on that trolley that we really like. One of the things, of course, is that they're movable, right? I mean, you can take them to the freezer where you have your biomass. Then you take the trolley to your ice, and instead of hauling ice and hauling all of these things to your trolleys, you take your trolleys there. That just really makes more sense. You don't have to be lugging things around, because moving these trolleys around the lab is really simple. And of course, the trolleys have those designs where you can put a bag in them. The bottom is special, that lid is special, the actual construction materials are special. There's all these little things that make this a winner. The bag feature, which makes cleanup so much easier. These big bags, like I've previously spoken, you can put a big bag in these tanks, just make cleaning of the actual tank so easy. The impeller design is also a great innovation of this system, that it generates two different flow patterns for different purposes, and I've spoken about this. I think that's one of the cool things. And also, the trolleys are just so energy efficient, so it's going to lower the consumption of ice, and it's going to make your life so much easier. The PLC is a simple system that we have, but it's also very feature rich. So it can be whatever you want it to be. If you want to go full GMP compliance, we can set up all of the monitoring that you will need in the data recording for GMP compliance, including temperature monitoring. So we actually have a thermometer sensor that you connect to the PLC, and so this allows you to continuously monitor that temperature. You can record your recipes. So if you're used to processing this specific strain in this specific method, it's really easy. You save your recipe, and next time you're processing that strain, you hit that recipe and you're good to go. And it's a really simple system to use. It's highly configurable, but it's really easy to use in the end. You're probably just going to have to push one or two buttons and get you where you need to be. When you're doing a continuous filtration pattern, there's a lot of accessories that you can connect to the outlet to monitor that fluid that's going through that pipe. And with a spectrometer, what you can do is identify the extraction endpoint. Not only can you identify the amount of trichomes that are being removed to give you a really good idea when you're done extracting the bulk of the trichomes, but also the production of contaminants like chlorophyll, things like that. So your trichomes in your graph are going to be coming down and your contaminants are going to come up. So it's going to be like a cross section, point of diminishing returns when it's no longer feasible to continue operating. And instead of stopping a batch and trying to identify that, you can visually see that representation of that process happening. So we think that's definitely a winner. So of course, how much flour a vessel can handle really depends on the type of material, whether it's dry, whether it's fresh frozen, whether it's trim, whether it's flour. So that really depends. But the ranges are somewhere between 40 to 80 pounds. But when you have really, really high quality material, you may only want to put 10 pounds in there, right? It really depends on the strain, how well it washes, and the quality of the material that you're putting in and the quality of the material that you are getting out. So the higher the quality, we recommend you put as little as possible. The lower the quality, you can go crazy. Depending on the material, one vessel could probably wash about 40 pounds per day. And that really depends on the material and your SOP, but safe to say, average 40 pounds. Now, if you have 4 vessels, depending on the SOP, you could probably wash around 500 pounds, and we do have some literature to suggest that. Yeah, I've seen this where some companies are saying they can do 200 kilos a day on one round machine. Maybe, I mean, it's possible. I have my doubts. I would really like to see some user vouch for it, but that may depend really on how their SOP is, right? Are they just washing once? What are they washing? How much are they filling these tanks? So that's really subjective. I mean, I doubt it, but if it is possible, you know, the way we do it is by adding a whole bunch of trolleys where the agitator stays busy throughout the whole process, because most of the process is like cleaning, filling, soaking. But when you have an overhead agitator, you're just able to increase just the throughput much more, because when one trolley is settling or filtering or cleaning, whatever, you always have something in there that's agitating. So that's the difference, and that's why we can guarantee that our throughputs are going to be higher than any system that has an integrated agitator. And you can kind of see this video on that process, how it's going from one station to another station, and the process just keeps repeating. So, you know, when you're using an integrated system that has the agitator inside, you know, you're going to get slowed down by filling it. Then you're going to get slowed down by soaking it. Then you're going to let it settle. Then you're going to have to filter out. All these things take time. And in the meantime, you're really not agitating. You're not working. So unless you do 200 kilos in one tank, that's all you're going to get, right? With a system that has an overhead agitator like ours and using many trolleys, you could definitely increase the output. The payback period for a system with one trolley is about 112 days, something like that. And a system with 4 trolleys is like 2 weeks. And the reason is this data is based on average labor savings versus hand washing. So that means that if you have 4 trolleys, I'm not saying that you're going to save all of that money in 2 weeks, but if you were hand washing the same amount, obviously it would take you many, many weeks to do that, to wash that same amount of volume. And so if you took that labor savings, then that money that you would save through hand washing, you would produce it much quicker with these machines with a lot less labor. So your unit costs, like your per gram labor costs, are so much less. And so you would get that money really, really quickly. And of course, these are just like ballpark figures. It takes certain assumptions on what you're processing, what your agitation, and how big your batches are, and yields. It does not take into account the increase in yield, how much money you're going to save through a higher yield, because generally when you're agitating, you get higher yields. It's just because the agitation is more efficient than if you do it by hand. What's my favorite bubble hash machine? The Bubble Magic. I think that that's the most successful machine out there, and it's great for entry level. And there's a lot of great things in the Bubble Magic. There are some drawbacks, of course, but in general, I think that's one of the better machines out there. On an industrial scale, of course, you need something more automatic, larger, and more continuous. So we did take our inspiration from the Bubble Magic, but we went far and beyond. Instead of just copying the design and be done with it, obviously, we took the good things about the Bubble Magic and ran from there. I think there's a lot of great machines out there, and they all have their pros and they all have their cons, and it's important for you to pick something at the budget that works for you and that fills all of your lab's requirements. So I don't think any machine is perfect. Some do some things well, some do other things well. It doesn't matter if the machine is the best out there. If it just costs a fortune, you may not be able to afford it. So it doesn't really matter. We just think that the Mesclatore is better than a lot of machines out there because it has so many little innovations that just make it easier to use. It's fairly priced, and it includes a lot of features that is going to make the user's products of high quality. It's going to make you money. It's going to pay for itself quickly, and it's customizable to many different lab sizes. And of course, our machines are made in Italy, so you know that the quality is there. Even though our machines are plastic, we use German plastic. So we're quality all the way at a fair price. With all of those little performance features, we think that this is definitely just an overall machine, very different from anything out there in the market, not just because it's the only industrial plastic machine out there. We put a lot of work into the Mesclatore, and so it does have a lot of features that make it so much better than other competitors. But in general, there's a lot of great machines out there. Fuck me.